Series and Sequences by
Lindsay Jones.
and Caitlin Watson. Symbols for sequences. A sub 1 is your first term, A sub 2 is your second term, A sub 3 is your third term, A sub n is your nth term, D is the common difference, and R is the common ratio. Arithmetic sequence. A sequence in which the same number d is added to the term before it each time. Common difference d is the value that is added to each term in the sequence. Some examples of an arithmetic sequences are 2, 6, 10, 14, and 18. 4 is added to each number. 2, 4, 6, 8, 10, 12 is where 2 is added to each number. Geometric sequence, a sequence in which the same number r is multiplied to the term before it each time. Common ratio r is the value that is multiplied to each term in the sequence. Some examples of a geometric sequence are 3, 9, 27, 81, 243. Each number is being multiplied by 3. 2, 4, 8, 16, 32, 64 is where each number is being multiplied by 2.
Arithmetic sequence formula. A sub n equals A sub 1 plus parentheses n minus 1 n parentheses times d. In the sequence 3, negative 2, negative 7, and negative 12, you have to find the 24th term. So to set up the formula, it would be A sub 24 equals 3 plus 24 minus 1 times negative 5. Negative 5 is d in this formula. So if you work all that out, it equals negative 112. Now we're going to pause and give you a little time to do one by yourself. Now if you had a little trouble, I'm going to do it myself to help you out. So you set it up just how you would set up the regular formula. A sub n equals 2 plus 12 minus 1 times 2. So you have to do PEMDAS. 12 minus 1 is 11. You multiply that by 2, which is 22 plus 2 equals 24. So the 12th term of this formula is 24. Now on to the geometric sequence formula. A sub n equals A sub 1 times r to the n minus 1. In the sequence below, 7, 14, 28, find the fourth term. A sub 4 equals 7, which is A1, times 2, which is r, to the 4 minus 1 power. Now here's an example. I'll give you some time to do it on your own. Now if you couldn't quite get it, I'll work it out for you. A sub 12 equals 2 times 2 to the 12 minus 1. So you do PEMDAS, which is exponents first. 12 minus 1 is 11. So you do 2 times 2 to the 11th power. 2 to the 11th power is 2048. And 2 times that is 4096. So A sub 12 equals 4096. I can't get up there.
Alright, so here are your symbols for sums. S sub n is sum, A sub 1 stands for your first term, A sub n is the last term, n is the number of terms, and r is the common ratio. Arithmetic series. This is used for adding all the terms up to the nth term when adding. You must use this arithmetic sequence formula first to find n. Once n is found, plug all the numbers into the sum of an arithmetic formula.
Arithmetic series formula. S sub n equals n over 2 times A sub 1 plus A sub n. Find the sum of 1 plus 5 plus 9 plus a few other numbers, and your final two numbers are 49 plus 53. So you have to find n first. You use the arithmetic sequence formula that we used earlier, so I'm not going to explain that. It's all right there. Then you use the arithmetic series formula. You plug in 14 for n, because that's what you're trying to find, over 2 times 1, which is a sub 1, plus 53, which is a sub n. So what you get is 7 times 54 equals 378. Now I'm going to give you a little time to work this problem out by yourself. Okay, that one might have taken a little longer because you had to find a sub n first. So I'll show you how to do it. A sub n. Okay, 22 equals 2 plus, since you don't know n, it has to be a placeholder, minus 1 times 2. So 22 equals 2 plus 2n minus 2. So since it's 2 and negative 2, you can just cross those two out. 2n equals 22, so you divide 22 by 2, n equals 11. So you go over here and you do s sub n equals 11 over 2 times 2 plus 22. 11 divided by 2 is 5.5, and 22 plus 2 is 24. So when you work that out, the sum of that arithmetic series equals 132.
Okay, now we're going to be talking about geometric series that are finite. These series are used for adding all the terms up to the nth term when multiplying. You must use the geometric sequence formula first to find n. Once n is found, you plug all of the numbers in the sum of a geometric formula.
So here's the geometric series formula. S sub n equals a sub 1 times 1 minus r to the n, all over 1 minus r. In the sequence below, negative 5, 15, negative 45, 135, n equals 8, which means you have to find the sum of the first 8 numbers in the sequence. A sub 1 equals negative 5, and r equals negative 3. So you plug all those numbers in. S sub n equals negative 5 times 1 minus negative 3 to the 8th, all over 1 minus negative 3, which turns into all this, and your answer is 8,200. So now I'm going to give you some time to try one on your own.